In this video, I'm going to go over complex numbers. I'll talk about the addition, subtraction, multiplication, and division of them. All of these are referenced on page 23 of the handbook. So starting off, what are complex numbers? Well, complex numbers include both real and imaginary numbers. So just to kind of review, what is a real number? Real numbers are rational numbers plus irrational numbers. So rational numbers a real number includes both irrational and irrational numbers, where rational numbers it includes things like the integers -4, -5, 1, 2, 3, as well as fractions of numbers like a 0.5, a 1/2, a 2/3, so on and so forth. Irrational numbers are things such as the square root of 2 and things of that nature. So what are imaginary numbers? Imaginary numbers are just simply the square root of a negative number. One of the things that are normally used to express an imaginary number, you'll see a lot of times I and J, and these are both used to represent the square root of a -1. So a lot of times we'll see those, but in the context of our handbook, we're dealing primarily with I is equal to square root of -1. And if we're looking at this, then it also means that the square root of I, or I squared rather, is equal to a -1. So we'll use this as we go along, but just want to point that out at this point. So just a little bit more about complex numbers. A lot of times we'll see them when I'm talking about addition. When we look at A plus IB, I just want to point out, because I'm a person who really likes graphs, so when we see this number, that this is considered the rectangular form, which is also the same as the trigonometric form. So let's draw it out. Let's graph it. So we've got this axis, the vertical axis is the imaginary axis, and the horizontal axis is the real axis. We've got some angle theta. We've got this point here, which is A plus IB, this being A and this being B. So for this lesson, we won't really use it much, but it does tie back, or we'll use this when we look at polar coordinates, but that ties back to our imaginary number. So I just wanted to highlight this in this video. So let's look at some addition. So let me start with when we add imaginary numbers, or when we add complex numbers, the real parts are added to the real parts, and imaginary parts are added to the imaginary parts. So that's a key thing to remember. Real parts add to real parts, and imaginary parts add to imaginary parts. So let's look at it. If we have A plus IB plus C plus ID, and we want to add that, well, let's write this out as we go through it so we can kind of see what we're doing. So this is the same as saying A plus IB plus C plus ID. So this is equal to, I'm going to pull out my real parts because real parts add. So we got A, let me write that a little neater. Got A plus C plus, I pull out my I, and I have B plus D. So that's addition. Now let's look at subtraction. Make sure you can see that. So subtraction, let's look at A plus IB minus C plus ID. Again, writing this out so we can follow it step by step. We get A plus IB minus C minus ID. So letting the real parts, grouping those together, and then the reals are added to the reals and the imaginaries are added to the imaginary parts. So we get A minus C, just pulling those in, plus factor out the I, and you get B minus D, and that is subtraction. Alright, so now let's look at multiplication. When we're doing multiplication, remember, as I pointed out before, I squared is equal to -1. We will use that in multiplication. So let's look at A plus, looks like a 9. Let me write that neater. So an example in multiplication, A plus IB times C plus ID. So let's multiply it out, simply FOIL it. So we've got AC plus ID plus I times BC minus BD. So again, pulling my reals to my reals and my imaginaries to my imaginaries, I get AC minus BD plus I times AD plus BC. And another example with multiplication is if we have A plus IB times A minus IB. So let's write it all out again. We've got A squared minus IAB plus IAB minus I squared B squared. So I can get this term and this term cancel out. And I know that I squared is equal to a -1. So this is simply A squared minus a -1 becomes a positive. So it's A squared plus B squared. And that's multiplication. So let's do one more thing. Let's look at division. When we're doing division with complex numbers, we have to convert the denominator to a real number. So we do this by multiplying the numerator and the denominator by, it's called a complex conjugate. So the complex conjugate of a plus I b is actually a minus I b. So let's look at that. So if we have a plus I b over c plus I d. Now remember I said we take the complex conjugate and multiply the denominator and the numerator by it. And if you do that, you're essentially you're not changing the numbers around. So let's do that. So we've got c minus id, which is the complex conjugate of the denominator. Multiply it by the bottom, multiply it by the top. So we've got c minus I d. So let's look at this top portion right here. So this would be a plus I b times c minus I d. Multiply all this stuff out, so we get ac minus I d plus I oh wait a minute, I missed one. Sorry about that. Let's start this over. So it's ac minus I times ad plus I bc minus I squared bd, where I know I squared goes to -1. And I can rearrange this, adding my reals together and my imaginaries together. I get ac plus bd plus I times bc minus ad. So that's going to be that's equivalent to the numerator here. So now let's look at the denominator, where we have c plus id times c minus id. And let's write this out. So we have expanded out. So we've got c squared minus I times cd plus I times c d minus I squared d squared. I squared is same as -1. This term and this term cancel out. So I am left with c squared plus d squared. So to rewrite this expression, I have got I've got AC plus BD, it's just this right here, plus I times BC minus AD over C squared plus D squared. And that's it.